Hello everyone, welcome to my new programming club. Today we will be solving another daily lead code challenge, and the challenge name is kth largest element in an array. So the challenge statement goes like this: given an integer array nums and an integer k, you have to return the kth largest element in the array. Note that kth largest element in the sorted order. Note the kth distinct element. What the problem statement mean by this statement is this particular line is, let's say you are given these numbers 1, 2, 2, 3, 3, 4, 4, 5. Now if I ask you what is the third largest number, then you have to consider the duplicates. Consider duplicates. What will be the third largest number? It will be the first largest number, it will be the second, and it will be the third. So the third largest number will be 4. And if you do not consider the duplicates, let's say I do not consider duplicates, I consider only the unique values. So 5 will be the first largest unique value, 4 will be the second largest unique value, and then 3 will be the third largest unique value. So it's in this case the answer will be 3. So as you can see, there are two different answers. This is when we have considered the duplicates, and this is when we have not considered the duplicates. So I hope you are able to understand what this line means, that kth largest element in sorted order, not the kth distinct element. So it is being asked that can you solve this without sorting? Now let's have a look at the constraints of the problem. So the length of the nums array is of order 10 raised to power 5, and the elements are in range minus 10 raised to power 4 to 10 raised to power 4. If let's say sorting was allowed, that then you could have easily sorted the array, and from the end you could have picked the kth number. The numbers were 1, 2, 2, 3, 3, 4, 4, 5. Then you could have just picked the third number from the end, which is 4. But here sorting is not allowed. So neither this single sort this sorting would have taken n log n time, n log n number of operations. And here is the length of this array. Let's call this array ARR. So length of this array is n. So if sorting would have been allowed, we could have just sorted the array once and returned the number from the end of the this sorted array. So since sorting is not allowed, so we will use a data structure. Heap is a data structure. It is of two types: min heap and max heap. But min heap is, in min heap, let's call this root, and these are the childrens of root. In min heap, all the children values are either greater or equal to the root's value. So the root's value is smallest among all the uh, values present in the heap. And opposite is true for max heap. In max heap, the root's value is largest among all the values present in the heap, and all of his children will either be having values in max heap all of his children will either be having values lesser than the roots value or equal to the roots value. So the roots value will be largest in min heap. The roots value will be smallest. And this will be recursively true for all the subtrees or subheaps that will be formed. For example, let's say this is the root in min heap for a subheap, then its children's value are either greater than or equal to this root's value. So I hope you are able to understand. To get the top of the heap, for the root of the heap, of one time complexity is required, of number of one operations are required, and one operation is required basically, so time complexity will be of one, and the number of operations to insert a value in both min heaps and max heap, insert value. This operation in total will require you log of size of heap number of operations. And those of you who are new to heap data structure, I will be providing a link for an article describing heap data structure. There is a bag. Each time the top of the bag points to the minimum value in the bag. Minimum value in bag, and bag is such that it is sorted in ascending order this way. And this is a bag. Bag here is nothing but a hypothetical construct that I have made to make you understand the logic of the problem. Now let's say there are less than k elements in the bag, and the given array is 3 2 1 5 4 6, 3 2 1 5 6 4, and k given here is k is given as 2. So initially, since the value of number of elements in the bag is lesser than k, so what you will do is you will be enqueuing at least k elements. Let's say I pick 3, then I pick 2. So as soon as I enqueue this 2, top will also always be representing the minimum value in the bag. This is the bag. So now since bag's size have become equal to k, and we are encountering this value 1, so we will check whether the value that we have encountered, what we will check, let me quickly change the color, whether this value is greater than value at top of bag, which is minimum value in bag. And if that's the case, we will remove the top of the bag and put this value in the bag. Since it's not the case, we will skip and move to 5. Now 5 is greater than the top of the bag, we will remove 2 and insert 5. Now since it is a min heap, the bag is a min heap, so the minimum value will always come at the top. So 5 will go towards the bottom and 3 will come up. Now you will move. Now you will check for 6. 6 is greater than the top of the bag, so you will remove this value 3 and put 6 instead. But minimum value is not 6 in the bag now, it's 5. So what you will do is you will remove this 5 and rearrange these values 6 and 5. It will be 6 here and 5 here. So now you will move further. Now this new value is smaller than the value of the top of the bag, so you will not bother about it. So what will bag represent is the bottommost value in the bag will be the largest value. And since we have maintained only k size bag, so this will be the kth largest element. So this is how we will get the kth largest element. And overall, the time complexity will be n into log of k. Since k is the size of the bag, each insertion operation will take us log of k time, and at most there will be n number of insertions. So overall time complexity will be this. What will be the space used? Space complexity will be nothing but k. Since only at a time k values are present in a bag, and we are not allowing a number of values to be greater than k. So these will be the complexities, and n here is 10 raised to power 5 into log of k here is, what is the order of k? Let's take the constants. It is also 10 raised to power 5. So log of 10 raised to power 5, it is lesser than 10 raised to power 8 operations. So your solution will be accepted. And you have not done any sorting here. You have just used the heap data structure. So each of the languages, both of the languages, C++ and Java, have their own heap implementations. In both of these, it's called priority queue. Let me quickly change the color. Based upon your preference, you can make this priority queue either min heap or max heap. Max heap or min heap, whichever you want to make this priority queue, it will act like this. So those of you who are new to this inbuilt data structure, in both of the language, I will be providing the links. So this is how you will be solving the question. Now let's quickly dive into the coding part. Basically, this is same as we have discussed. Priority queue is nothing but the heap data structure that we are using. So in this case, we have comma min heap. So this will always top of this heap, or say root of this heap, always be the minimum value in the heap. So if the number of elements are lesser than k, if the number of elements in the min heap are lesser than k, then we will keep inserting the values in the heap. Inserting the elements in the heap. Else, if the top of the heap if the top of the heap is smaller than the current current or say element being considered, About the top of heap, min heap, and insert the new element. At last, you will be returning the top of the heap. At last, the top of the heap will represent kth largest number in sorted order, because you have maintained only the k size heap, and at present there are k largest numbers, the elements present in heap, and top of heap is the smallest of them. So this is how we will be solving the question or the problem statement. So if you are still having any doubts, please feel free to ask them in the comment section. Thank you for watching. Thanks.